Okay, students, let's get started on our lesson 1.5, which is about functions. Most of the things you learned in Math 1. So this is pretty much 90% of it, it's review from that. So basically, we will be reviewing. So let's talk about sets. Sets is when you use the braces, okay, and you put anything inside. In our case, most of them will be numbers. Um, so these are called components, okay. Then so let's talk about this one. So this has braces, and then inside in this set, it has a collection of different numbers. So you have 1, 3, 5, 7, and 9. Now they can be related to each other, or we just put them. Um, so a set basically is a collection of objects um, whose contents can be clearly determined. Then the objects in a set are called, so these we are talking about, these are the objects 1, 3, 5, 7, and 9. So these are called the elements. Okay. Now we use braces, these two, the curly braces, to indicate a set, and we separate the elements with comma. Okay, so we have commas there. Now a relation is also a set, but it's a set of ordered pair. Ordered pair means where you have two numbers, so let's say 3 and 5. So this is one ordered pair. So when you have a set of ordered pair, you call it a relation. Um, the first the first number or first element in that ordered pair is called domain. So this is the domain. Generally we also say that it's a variable x. Then the second one in each ordered pair, it's called the range. Generally we represent it with the variable y. Okay. So in this, it is asking find the domain and range of the relation. So our domain will be these years. So 1994, 95, 96, because in each ordered pair, that's the first one. Then the range will be the one that comes after. So in each ordered pair, so these are the range for this relation. Okay, now there's another term that is called function, and function is a specific relation basically, where so you will have ordered pairs in there. In that, it's a set of ordered pairs. It is a relation, but each domain will only have one range. So basically you cannot have this that 3 is related to 5, and in the same set 3 is again related to 7. You cannot have that. So the domains, the domain values, they cannot repeat. Okay. So now this one is asking determine whether each relation is a function. So you have 1 is related to 6 Now 2 is related to 6, 3 is related to 8, and 4 is related to 9. You can see the domain values, they did not repeat at all. So because of that, we will say yes, it is a function. Okay, now let's come up here. So you have 6 and 6 is related to 1, but again 6 is related to 2. So you cannot have that domain is related to two different range values. So because of that, it is not a function. Okay, this one is actually missing the arrows. So if these are related like this and this one is related like this, then let's find out um, which one is a function and which one is not. So this one is related to 6, okay, and then 2 is also related to 6, so which is totally fine. What we cannot have is one domain value is related to two different range values. So this is not allowed. But if two domain values are related to one range value, that is totally okay. So this is a function because one domain is related to one range value, okay, but this one is not a function because 6 is related to two different range values. Okay, this one is again, this one is asking about if it is a function or not, and also we need to write down the domain and range values. So let's write down the domain and range values first. So the domain ones are the ones that comes first in each ordered pair. So 1, then 3, then 5, and then 5 again. So we don't need to repeat it. And the range values are 2, 4, 6, and 8. As you noticed, 5 is repeating in the domain with two different range values, which is not allowed, so it's not a function. Then this one, the domain values are 1, then 3, 6, and 8. And the range values are 2, 4, 5, and 5. We don't need to repeat it. So you'll say 2, 4, and 5. Okay. Now you can see we are not repeating the domain values 1, then we have 3, then we have 6, and then 8. So it is a function. Okay. Now functions, they can be um, functions, they have to be smooth and continuous graphs, meaning they cannot have sharp turns. So look how smooth the turn is here. Okay, sharp turn is something like when you go up and you cut down. So this is not a function. Okay, so then if the well-rounded smooth corners we have, then that is a function. Okay, so, and if you don't need to lift your pencil, then that means it is a continuous graph. So both the things make it a function. Okay, so these are all, both of them are functions because you are not lifting up your pencil, and the corners that we have, they're well-rounded smooth corners. Okay, So what will not be a function is if you have a function like this. This is not a function because the corner that you have, the turn that you have, is not a smooth turn. So it comes pretty sharp. It's not smooth. So because of that, it's not a function. Also, it will not be a function if the graph is broken. So let's say you have here and then it's broken, because if you are trying to trace it, then you have to lift your pencil. Because of that, it's not a function. Okay. Now it's called vertical line test to find out if it is a function or not. So what we figured out here is it will be a function if the corners are smooth and you don't have to lift your pencil. There is one more way to find out if it is a function or not, is when you lift your um, when you are using a vertical pencil. You hold your pencil vertically and you go through the graph, and if it is passing through more than one points, then in that case it will not be a function. But when you are moving your pencil vertically through the function graph and only one point is passing each time, then it will be a function. So it's called vertical line test. Let me show you how it works. So just think that this is your pencil. Okay. Now I am passing it through. So look how you have 2 points, one here and one here, that is passing right now. So this will not be a function because each time, if you see, there are 2 points that are passing through when you are moving your pencil. So this is not a function. It fails the vertical line test. But if you come here, then you will see only one point is passing each time. So this will be a function. If you come here, this will also be a function because each time only one point is passing. Like right now, this is the point. Right now, this is the point. Only one point, only one point. So these two are passing the test. If you come here and if you come and look here, then one point is here and one point is here. So at a time, 2 points are passing. So because of that, this is not a function. Okay. So this is how you find out using the vertical line test if it is a function or not. So we figured out this is not a function, this is a function. So yes, yes for that one and no for this one.